here is the vector application problem with two vectors. The first vector is an airplane flying 200 miles per hour along a bearing of 320. And I'm going to go ahead and draw a table for each vector and add it for the resultant vector. Okay? So my first vector has a bearing of 320. So bearing means you start from north, right? And you go 320, so that's 270. And how much more do you go up? 50. So this is what we need to find the x and y component. This is 50. This is 320, and the reference angle is 50. And it's on the second quadrant, so we already know x must be what? Negative. And y is positive. So what's the magnitude? It's 200. So it's 200 cosine of 50. And it's 200 sine of 50 to find your x and y. From here, you go 320. So this is 270. How much more do you have to go? 50. This is 40. If you want to use that angle, then you have to switch sine and cosine. That's why I'm saying you have to use a reference angle. Second quadrant, x is negative, y must be positive. When you plug into the calculator, it will most likely give you all positive. So we plug in, you have to determine the sign. So now you plug it in. 200 cosine of 50, 200 sine of 50. So I get 128.558, 128.558. But remember, it is negative. 153, give me 1 second. 153.209. Air is moving with the wind speed of 60 miles per hour, a bearing of 190. So bearing, you start from north. So that's 180. So you go 10 more, right? This is 10 degrees. What is the reference angle? 80. You have to use 80 if you want to plug into that formula. But it's on the third quadrant, so you should know x must be negative, y must be negative. So the magnitude was 60. So you can do 60 cosine of reference angle 80. 60 sine of 80. So then you get negative 60 cosine of 80 and 60 sine of 80. And I know I have to add negative even I didn't put it. So it's 10.419, 10.149, 419 negative. And I have 59.088 must be negative. So that's a component form of a wind vector. I resolved the vectors. That's what it means to resolve. You have to find x and y components. So now what are we doing? We are adding these two vectors. So what do we do? So I'm going to call this vector P, plane, vector W for wind. Now we are adding P plus W. So what do you do when you add vectors? You add the x's together and y's together. So here they're both negative, so it becomes bigger negative. What is it? Plug into the calculator. Negative 128.558 minus 10.419. So negative 138.977. My resultant vector. And I add 153.209 plus negative, meaning minus 59.088. So 94.121. So that's my resultant vector in a component form. Right now, it's going to tell you the quadrant. You can easily find its magnitude. And by knowing where it goes, so always graph it, you can find its, what's the question? You have to find the direction angle. You can find the direction. So first draw it. So here's negative 138 and 94, so it will be somewhere here, right? This is negative 138.977. Your y is 94.121. So what is easier to find? The magnitude, the speed. So what would you do to find the magnitude of vector p plus w? You do square root of 138.977 squared plus b squared 94.121 squared. So 138.977 squared plus 94.121 squared, and you square root it. So you get 167.849. 167.849, what? What's the unit? Miles per hour is now how fast the plane is going. So as you can see, the wind is blowing in a different direction. So from 200 miles per hour, your plane is going a little slower, right? Yesterday, when it was going in the same direction, the airplane were going faster, right? So now, what is it? We have to find the direction, meaning we are looking for this angle right here. Do you guys see it? But how do you find this angle? It's going to be always arctangent of y over x. So arctangent of y, you can just put the positive values after values. 94.121 over 138.977 will be the theta here, this angle. So it is second tangent of 94.121 divided by 138.977. I get 34.107. 34.107. So for this case, when this is 34.107, would you add 180? Add 90? What would you do? Yeah, you will subtract from 180 to get this. This is the direction from positive x-axis going counterclockwise. So what would you do? This time, you will subtract from 180. So you get 145.893 degrees of what? Of, you have to say, of direction. Not of bearing or heading, it's of direction.